Привет, Moscow. That's the only word I learned from my Russian friends. This is a different word that I know, but I can't pronounce that. So I'm using Привет. And thanks a lot for coming to this hall because, I was telling her that it's even harder for me to come inside with the smell of food. So thank you so much. I cannot guarantee, but I'll try my best that your time is worth my presentation. So I'm Renu, and I work for an organization called Grab. What is a Grab? So Grab is basically a taxi hailing platform which started in 2012. It's serving the Southeast Asian countries. So basically, if you want to have a very clear example of Grab, let's just say it's similar as Uber, okay? But the fact that we acquired Uber's business in this April for entire Southeast Asia. So that means Uber is no longer working in Southeast Asia. So that's kind of a very big deal for a company like Grab, which was hyper-local, and Uber, where it's an international organization, right? So it's in 7 countries right now. The circle, why did I use the full map and not zoomed in that particular area? I'm just trying to show you that the world is so big and they are just working in a very smaller part of the map, very smaller part of the world. But recently they clicked their 2 billion rides. So that gives you an estimation about how big is their business. And as I said, they started with taxi hailing, but they were not limited to Grab Taxi. Now they have Grab Food. After the Uber acquisition happened, they had to come up with something which serves the food delivery because Uber Eats was there in Southeast Asia. So we have Grab Food, we have Grab Delivery, we have our own payment system called as Grab Pay. So, and many more services, and I actually worked on it. So what all 7 countries do we serve? It's Indonesia, Singapore, Myanmar, Philippines, Vietnam, Thailand. What else? Malaysia, thank you. Malaysia. So yeah, these are the 7 countries that we serve. And yes, our next target is to win Indonesia because that's the market we look forward to acquire. Okay, now today, what are we going to do? Because the time is precious, lunch is, I don't know whether we will get the lunch or not, but okay. I'm gonna do some bullshit for around 20 minutes or something. We're gonna talk some bullshit. Then we're gonna do some important part. I'm gonna demo some Android Studio profiling. And then the most important part. We have a beer party tonight. Okay, so let's get started. Android Studio profiling. I know my talk title says app stability, don't crash the party. And here my title says Android Studio profiling. How are they related? So why did I choose this topic? So I attended Google I/O 2018, this year. And I attended a few talks about Android Studio profiling, and I realized how basic profiling tools are. And yet we underestimate them. To be honest, I have been an Android developer for around 4.5 or 5 years, but I have never used Profiler, never ever. Whereas the Profiler is right in front of your eyes, where you code every day, and you get the basic facilities in that particular IDE, and yet we don't use it. Okay, Android Studio profiling. Okay, you chose this Android Studio profiling topic. Now, what is app stability? So basically, app stability talks about the expectations of an end user from your application. Okay, I'm a mobile developer. I work on main Grab application. What do my end users expect? I guess these are the very, very basic low expectations of any end user of any mobile application. First of all, your application should work as expected. The user experience should be smooth. Your app should be performant enough. It should not drain your battery. It should not eat your GBs of data. And it should be crash-free. So this summarizes your app stability criteria. So, if you look at these points, if you do not have any of these issues, your app is stable enough. And this is the study from Google I/O 2018 that when a user leaves a 1-star review on Play Store, 42% of the user mentions the stability or the bugs. That means the user mentions the app is not stable. And when they leave 5-star review, 73% of them mentions the speed is good, the design is good, the usability is good. That's again, app stability. So what trend are we seeing here? We are seeing here that app stability determines mainly what kind of reviews you'll get on your Play Store. Is there any mobile developer here whose app has 5-star on their Play Store? Oh, do you? Okay, then maybe from today onwards you can work on that and get 5-star review. So, okay, we got it. App stability can get you 5-star reviews, but what if you're not getting 5-star reviews? That means your app is not stable. That means your app is unstable. Wow. And what is the very first criteria of app being unstable? Like we talked about, app should be crash-free, right? So if you have crash, your app is unstable. So what do you do when you have crash? How do you eliminate it? How do you fix it? I know it's boring theory, but you gotta bear me for a few more minutes for this. So you can use Fabric or Crashlytics to get the crash reports. So crashes are those stability criterias when you know the root cause is right in front of you. The crash happened, you saw the stack trace, you went inside the code, you debugged it, and you fixed it, and boom, your app is crash-free, right? The second instability criteria, you can assume it's a battery, like Droid having battery. So is the performance, and performance instability criteria is something which is very hard to debug. Imagine your users are saying that, oh, your app is draining my battery. What do you know? Which component of the app is draining the battery? Users are saying that, oh, yesterday I topped up my network data and all of it is gone while I was using your app just for an hour. How do you tell which component of app is eating up those GBs of data? So this is performance. So this is not as straightforward as crashes, like you get the report and you debug it and you remove it. So this is not sometimes visible with naked eyes. And if I can give you an example, in Indonesia, like which Grab is targeting, we don't have very high-end smartphones over there, like majority of them. So they have lower-end smartphones, and this become a prominent issue for such kind of markets. Okay, performance, that was one issue. Now we talked about smooth user experience. So if your user does not have a smooth user experience, that means there are some issues with the way your UI is rendered. So this becomes the third instability criteria. Okay, now what's in rendering? We all know that for a smooth user experience, each frame should be drawn in 17 milliseconds. That means your app should have a 16 FPS rate to give a smooth user experience. But what if your frame is not being drawn? If your frame took more than 17 milliseconds, then your system, Android system, is forced to skip that frame. And you will start seeing some lagness, some janky UI in your application. But that's not the monster. The monster part is, because when you draw a frame, there are two parts of it. There are business logic as well as the UI logic, like rendering the UI onto the device. So the bigger monster is, let's assume that your frame used 700 milliseconds to draw. And if you see that, like 1 second is 1,000 milliseconds, that means for 1 second, system could not use that frame to draw. So your app was stuck and unresponsive for almost a full second. So this is a very big monster, and you should never, ever have this. Like, a lot of applications have janky UI, like you can see that. But frozen frames should be avoided. So this becomes our another critical instability criteria. Okay, then now you know your app is unstable. We said that crashes can be tracked using Crashlytics. How do I track my battery? How do I track my network usages? How do I track whether I have a janky UI or frozen frames? So there comes AndroidVitals. So Google in 2017, they launched this program called AndroidVitals. And it's nothing fancy. It's just a dashboard in your Play console, Google Play console. It collects and shows the data over there. Now, what data? What data are we talking about? Okay, so the data, it's battery usages, stability. Here, stability means crashes. Your render time. Well, it's not working anymore. Sorry for that. Yeah, your app startup time and your permissions. Let's go back here. So battery usages, we said, okay, if your app is eating a lot of battery, now how do I track it? You can use AndroidVitals. Stability, crashes that you can already track using Fabric and Crashlytics. Render time, the thing that we just talked about. If you have a janky UI or you have a frozen frame, Vitals can tell you. App startup time, this is again one of the bigger monster for the app performance. Imagine the user clicked on the app icon and for a few seconds they don't see anything. They just see the splash screen. We had this issue. We had app startup time for around like 4 or 5 seconds. And that's horrible. Like imagine nothing happens for 4 or 5 seconds. I mean, I look like a dumb, like I clicked on app and nothing happened. So AndroidVitals, it records how much time it took for a user to open your app and to actually see something inside your app. And the permissions. So since the marshmallow comes in, we have runtime permissions, and user is free to deny for any permission that we want. So how do we know? Sometimes we ask for like many permissions which are actually not required. So with this, we can track how many permissions have been denied by the user, and then you can decide whether those permissions are actually useful or not. Okay, now you have this data. What the hell is wrong? Okay. So now you have this data. Now it's just like a room full of some important information, vital information, but it doesn't make any sense until you can filter it based on your use case. So there comes the measurement dimensions. So you can filter your data based on all these dimensions. You can decide whether a specific app is causing these issues or a specific Android version is causing these issues, maybe the wake log tag that you have defined, the ANR activity name, the ANR type. You can use any of these dimensions to filter your data. Okay, I was asked to share some screenshots of how exactly Vital dashboard looks like. So it's not a real time. I just took this snapshot from Google I/O presentation. Actually, most of my slides are from there. So this is one of these snapshot of Vital dashboard. There you can see that they are showing the stuck partial wake logs, excessive wake ups, excessive network usages for your performance data. You can see the last 30 days data, previous 30 days data, and you can click on any of the details and go further dive into it, what exactly is happening. This is another snapshot of Vital dashboard. As you can see, we said that we can filter using APK. Maybe your previous APKs were fine, but the current one, we introduced some bugs. And so this will help you in highlighting which exact APK is causing the issue. Okay, if your app is becoming a bad guy, that means they have some threshold based on the other app's data. So if your app is going below that data, so that means your app is a bad guy. And this will be highlighted right on top of your Vital dashboard. This is just another simple stuff. You can opt for notification setting that if any of the Vital data type went into the bad criteria, it can notify you for that. And actually, this is the data from Google I/O. So since the time people started using AndroidVitals, they have seen 4% increase in 5-star reviews on Play Store, a decrease in 18% of 1-star review for stability and bugs, and a decrease by 21% in resource usages. And another example to amplify the usages of Vitals is you can see like Starbucks, their ANR rate got decreased by 70%. And this is actual data, like this is not, I'm blabbering about anything. And their crash rate got decreased by 85%. And same for Kilo, ANR rate got decreased by 95%. The daily active user, DAU, got increased by 9%. And I guess that's enough to say that AndroidVitals are making a change in the Play Store. Okay, now, here comes the important part. So profiling, we said that, okay, our app is unstable. We have a full lot of data. We know our app is not performing well. App is eating up the battery, the network usages. What do I do about it? The very basic thing, you go and profile your app. The very first thing that you can do is network profiling. What does network profiling do? Network profiling, you can see the network thread details, the request and response details, and the header details. Network profiling was there in 3.1 as well, but they recently added the request response and header details. I'm just gonna run through it like quickly so that we can go to the demo. So energy profiling, this was added in 3.2, and this is actually quite important, and I will be demoing, so we will be seeing it live. So energy profiling, you can defeat the battery beast here. You can find out how many alarms you have. You can find out how many scheduled jobs, how many wake locks you have, how many wake-ups you have. Memory profiling, it will tell you the memory usages, the garbage collection, live memory allocation. The recent thing that got added in 3.2 is the native and JNI references. So earlier 3.2, what used to happen, if there's a memory leak from JNI layer, it was hard to find out. But with 3.2, it's very easy. Like, we can win them. It's actually one of the most profiling tool. It's, you can find out the thread details and the process details and the resource usages about if you're, like, it's a multi-core world, right? So how many cores your application is actually using, on which thread your process run, and how many resources it has been using out of the CPU. So it's kind of pretty cool, actually, and quite important. You can use CPU profiling to figure out how much time a function has taken to draw itself. For example, you have a custom view, you have a custom onDraw method. Using CPU profiling, you can find out whether your onDraw method took more than 17 milliseconds or not, and whether you have a janky or frozen frames. And the time consumption, yeah, that we just talked about. Actually, in 3.2, they recently added sessions. So sessions is something, okay, I have a buggy app, I did my profiling, I know what are the root causes, I fixed them, now I profile it again, and now I have a new set of data. Now how do I compare whether this works? So this sessions, it's kind of a mechanism that lets you store the profiling and retrieve it later on to compare your fix. Okay, demo. I'm going to switch to demo. I hope this, wow, all of you know my password now. I have built this shitty application. Now, I'm not that bad developer in general, but I had to do a lot of wrong stuff in this profiling application so that we can make it a potential use case of energy profiling. So there I have, let me just drag it a bit here. So I have here one change background function, which is at the bottom. So if you click here, it's going to make a network call. It's going to download an image and set it as a background. So that we're going to use for network profiling. On top, you can see stopwatch and timer. There, I'm unnecessarily using wake locks and alarms, which can help us in determining the energy profiling section. OK? I'm just going to profile it for you. So, whoa, what happened? Allow me for a second. OK, this is how the profiling section looks like. Is anybody familiar with Android profiling here? A few of you. OK, I don't know how useful this is for you then. Oh, I'm cheap. I didn't pay for ad-free sessions. OK, so this is the main agenda that we are here today. You see the 4 sections here: CPU, memory, network, and energy. And in the right, I hope it can highlight. Yeah, here. This is what I meant by sessions. So you can click on plus, and then you can create a new session. You can stop the session, and you can retrieve the previous sessions as well. OK, I'm going to click on network. So there we are. No network operation is happening as of right now. So I'm going to click on change background, and let's see what happens. Oh, the background got changed. And here we see a spike. You just select that frame, and then you can see the full details. At the bottom, you see the connection view and the thread view. In the connection view, it just shows what it tried to download. In thread view, it showed which async task it used to download your image. OK, let's go to the connection view. This is, again, an important part. So you clicked on this image, and there you can see the response, the request, and actually the call stack. And if you click on this call stack, it directly takes you to the file, the location of that code. Now, how it can be useful? Imagine you build this code, you build this app, and you left the company. Very general case, right? Now, but you made mistakes in this code. Now there are other engineers who are trying to debug and they don't know which class is exactly trying to download this file. So they can just use this call stack method functionality. They can just click and they can just go there. Okay, so you see the pink touch here. It's the pink touch. Okay, I don't know where it is pointing, but you can see the main activity line and the pink touch over there. That means your app has been intervened by a user action because I touched over there. So the point that I'm clicking here is like go to the current frame. Okay, we are in the current frame. If I click it multiple times, you should see multiple network thread details. Only if it works. Okay, we are seeing. As we can see, we saw the multiple touch actions as well. So you can just see all the details of all the network calls that happened and the thread views that happened. As you can see, not all of your calls were happened in the same async task. One happened on number 2, one happened on number 3, and one happened on number 4. So this can be useful when you're doing a multi-threading programming in determining where exactly is your process running through. So yeah, this is how you can find the data for your network profiling. Now let's switch back. What happened around this time? Okay, now let's go back. So you see the network spikes around that time. You can see even the CPU spikes, even the memory spikes, even the energy spikes. That means your system did try to do something at that time. So maybe you can use this full snapshot in order to figure out whether this was expected or not. Maybe you just downloaded the image, but you didn't do anything, but because we tried to render the image on our UI, so that means definitely there were CPU instructions. So this was the basic network profiling. If you move on to the energy, you can see like clearly that how much energy was being utilized by your system. Now here's an interesting point. So if you hover over it, you can see that there are mainly 3 points which consumes energy of your system. One is CPU, one is network, and the third one is location. And our grab, like in our case, the grab, it's a location heavy based application. Like we keep on fetching the current location user. So no wonder our users have been complaining that, oh, your app is the worst app in the world because it eats up my battery, it eats up my data. So we have to be really, really careful about when we use location and network and how intensive CPU operations are. At the bottom, you can see that there is one location. You see this purple line? Just like the system and the purple line. And if you hover over there, you can see at the bottom there are 3 things: location, wake locks, and alarms and jobs. And this purple line denotes that there is one location request. And inside the app, you can see I have like switched on the location updates. If I switch off the location updates from here, okay, and if you try to run this purple line should have been gone, and yes, it is gone. So now if you hover over here, so there should not be any location in system events. If you turn it on, then you should again see this purple line coming in, and yes, it is coming in. So what you can do is, sometimes what happens, you just want to retrieve the location once, and that's it. You want to perform some operation, you retrieve the location, and that's it. But when you profile, you see, oh, your app is still trying to fetch the location. So that means there is something wrong with your application at that point of time. Okay, now what we can do is we can just click on stopwatch. Okay, it's a beautiful stopwatch that I made. And if I say start, you can see one red line just below the purple line. Now what is it? Let's zoom into this. Okay. Why isn't it showing me? Okay, let's go one by one. So when you zoomed into this, and you below in the description window, you can see there's one location request, and then there is another one which is wake lock. Now you click on wake lock. I acquired the wake lock, which was not really necessarily for this application, but I still did it to to use the example. Now you click on this wake lock, and you can just click on the call stack, and you can just go right to the code where I'm acquiring this. Now what actually my function is doing, whenever I click on start stopwatch, I'm acquiring a lock, and whenever I'm doing stop, I'm releasing that lock. So that means if I stop my stopwatch, which I stopped, this red line should have been gone. And yes, it is gone. So that means if you try to zoom in this, you will only see one location request. So that's again, that means if you have a wake lock request, and imagine if this red line would not have ended here, that means there is something fishy going on. We can try this again. We can do start, and we can again see the line, and we can do stop, and we should not see that line. Now the third point is, if you go to timer, for timer, I'm using alarms. Like if it's a 10 seconds timer, I'm setting an alarm and then trying to perform some operation when the system receives the alarm broadcast after 10 seconds. So I just did 10 seconds timer. And as you can see, in my timeline, in the system timeline, now I see 3 lines. Now what does these 3 lines means? We can just zoom in here. And now in the pop-up window, the hovering window, you can see there's one location request going on, there's one wake lock, and there's one alarm. And as again, in the description event, you can just see, like this is the alarm, which is RTC wake up, and you can click on it, and you can directly go into the class where I'm setting the alarm. Now, what did we say? That energy combines the CPU, the location, and the network. So that means around this time, my CPU usage should have been higher. Oh, it went away. Let's start the timer again. So after 10 seconds, when the alarm goes off, I should see a spike in CPU, and which I do. Because when I receive the broadcast, like this, this CPU section, because when I receive the broadcast, I am performing some operations. Like for example purpose, I'm doing some Fibonacci series. So I can see that at this time, my app used CPU for like 25%. And here in this, like all the threads and all the system information that you see, like the green means this green, it went away. 1 second. So whenever it's green, that means the thread is available. When it's yellow, that means your thread is waiting for input-output operation. And when it's red, that means your thread is blocked and it's doing some operations. Okay, the last part that I want to do here is, because I'm going to go to stopwatch again. And I'm not using a simple on-draw method. Like it's a custom view in which I'm trying to format the string again and again, again and again, to find out whether I can actually simulate the exceeding 17 milliseconds behavior. Okay, so but it doesn't work directly that way. So you have, for CPU profiling, you always have to record and stop, and then only you can sample it. That's the hard part. Yeah. In these options, oh, come on, stop. This is the worst nightmare. It always happens with me in all the talks. It doesn't stop. And no, I didn't do anything wrong. It's with the Android Studio. The fault is with Android Studio. Where am I using the 3.2 stable version? So just an example of how CPU profiling looks like. You see here these 4 options, which are call chart, flame chart, top down, and bottom up. These are just the visualization of how your method stack will be looking like. So you can just zoom into anything, and if you hover over there, that means this is some system method, and so where did I want to go? Just a second. Let's try to record it again. One information about the sample, instrumented, sample native, and system trace. Sample Java, basically system captures your Java method string at different frequencies. I'm sorry. What about the instrumented Java? So what happens in sample Java? Because it happens at frequencies, so there might be cases that system missed your method stack. In instrumented Java, each and every method call will be tracked. In sample native, in instrumented Java, that's an overhead as well, because with timestamp, each and every method is tracked. In sample native, it's same as sample Java, but for your native methods. System trace is basically how exactly your process is interacting with CPU. So let's do this actually. And system trace then will define how much time exactly your application took. Do we have still time? 5 more minutes. Okay. Okay, or maybe we can just go into, because again, the stopping and recording will take time. So as we saw, like call chart, this displays like this different function, how these functions have been called. Flame chart looks red. And top down and bottom up, the only difference between top down and bottom up is like one displays the callees first and another displays the callers first. So that means if A, B, C, A calls B and B calls C. So in one of the cases, it will display A, B, and C, and in another one, it will display C, B, A. That's the only difference. And I'll take my shot. I'm going to record it again. I recorded it. It's going on. And as I explain about like the different sessions, like you can just click here and see the previous trace as well. Okay, enough of this. I'm going to stop it now. If only it stops. It did. So these were the green and yellow things that I was talking about. Like you can see, like green means that the thread is available to perform any operation, and the yellow again means that it has something to do, but it's blocked by an I/O operation, that it's waiting for I/O resources. So I'm just gonna zoom into this. Where did the function go? Okay, I'm gonna stop it, yeah. As you can see, like which different threads your application went through. There are other render threads, just don't worry about that. Profiler example is my application, and it will just tell you like which all thread it did go through. You can again like go to the flame chart and have a look at what all functions did. Come on. Like because okay, we did system trace, so it didn't like we didn't do sample Java, so it's just see this on draw method, how many times, how much percentage of the CPU it used, and how much time did it take. This is how you can find out whether you have any janky UI or you have any frozen frames, which is taking 17 milliseconds or more than that. And just for the sake of it, I'm just gonna show you this time view, which I'm actually using to draw the stopwatch timer. So here in onDraw method, so there you go. In this onDraw method, I'm doing calculate current time. And if you go to calculate current time, it's doing some formatting of the time and then doing it, which was definitely not necessary for this profiler example. So this code is available on GitHub. So if you go and you remove this code and you remove the custom view and you just do the set text view, you can see a huge difference in the time it takes to draw the text view. So I suggest that you should do that. And that's about it. That sums up my profiling sections here. So yeah, that's all. Thank you so much. I should stop my stopwatch too. Yeah.
Вопросы?
Wow. Quick enough.
Thank you very much. And you said that you use the Google Vitals to track your crashes.
Yeah.
But do you use something like Crashlytics or another tool to see your crashes?
Well, to be honest, Grab does not use AndroidVitals. So, but we definitely use Fabric and Crashlytics. We use it on daily basis. Like we monitor our performance based on Crashlytics. That's how we do the staged rollout. Like if it looks stable, then only we increase the rollout. And yes, we get the crash report, and that's how we fix the issues from Crashlytics.
Thank you very much.
Hello, I want to ask about starting uptime.
Sorry, startup time?
Yes.
Okay.
All of us trying to start up as fast as we can, and
Yep.
we show a splash screen. But after that, many of us had to show another splash screen, custom splash screen.
Because it was
Because
taking too long.
Yes, because
Yeah.
we need to load something and
Yeah.
some stuff. But sure, we should show something for user that will be useful for them.
Yeah.
Maybe Grab has any solution and can share us what to do to show something useful, but not to show not useful splash screen again.
Sure, sure. Well, actually, funny example of that, like we did have the startup problem. So we started showing splash and then we started showing green color background just to, keep user engaged, like, okay, something will come up. And our app startup time was horrible. And believe me, it has reduced from some 5 seconds or something to like just 1 second or even less than that. Now, how did we achieve? Like in app startup time, we used to call 7 or 8 different APIs. Like that's what usually happens. Like we collect the data of any user, then we decide which screen to show. But what we did was like definitely it needed some refactoring, and we did lazy loading for all the APIs. Like instead of calling all 8 APIs together, we, like for example, Grab shows map, right? So, but user does not immediately start interacting with map. So what we do is we show the green splash screen and then we load the map. And then we keep on calling the APIs in the background, but we do not let user wait on splash. Because by the time user starts interacting on the map, we have few data ready to show. So that's the one trick that we use, that we don't necessarily have to wait on splash to show user actually something. Because, and you don't have to call all 8 or 10 or whatever number of APIs together. You can bundle those APIs on whatever is necessary first. And so we call like 2 APIs up front, we get the data, we show something to user, and we keep on calling rest of the 6 APIs in the background. And we keep on updating the data wherever it's necessary. So like earlier we used to wait 5 seconds for all 8 APIs, but no, we just wait for like little more than 1 second for 2 APIs, and we show something to the user, and then it keeps on calling the rest of APIs in the background. That's what we did. Does that answer your question?
Thanks a lot for the talk. I wanted to know if you have any specific workflow on when to spend some time in the profiler. So do you do that like every week or every release, or do you wait to have a stability problem to dig into it?
Okay, that's a good question. So as again I said, like we started receiving horrible reviews on Play Store, and we did not used to we were not used to profiling, and especially for the Indonesian market. So we started getting reviews about like, okay, battery performance and all these things, and that was the hint for us to go into the profiling. We still do not use profiling on regular basis, to be honest, because things have improved a little better than earlier. But if I say, like, definitely use AndroidVitals. AndroidVitals can give you a hint about when to debug and when to not. But then again, profiling does not tell you what's wrong with your application. Profiling just tell you what's happening inside your app. So you can keep on checking with every release whether it's meeting your expectations or not. And apart from that, you can just check Vital Dashboard, and if it's being targeted as a bad guy, then I think that's the hint that you should go for profiling. Yeah.
Thank you.
Так, ну, наверное, это все. Давай, давай. Можно, пожалуйста, микрофон в 3-й ряд?
Thank you for lecture. I want to ask about energy consume. Can you give a big tip to how to optimize energy consume in your app from your practice? What what you can say about that, and just give a tip from your practice.
Okay, sure. So as I said, like location, like in our case, we also had this, like Grab has, I think it had almost all the problems. So, but we did try to solve all of them. So energy consumption, as we said, like it's mainly consists of CPU intensive operations, location, and network. So that means like it's already blotted down to 3 different areas that you have to focus on. Then again, like I guess network is something mandatory for all the applications to perform client-server side communication. But what was with our system was that, let's say location is required on specific screens, not in all the screens of your application. So if user is not interacting with location specific screens, you should really stop fetching location. Yes?
Hello, thank you for your presentation. And one question came to my mind. What person or who should do the profiling? You have some dedicated person, any programmer can do, or some architecture, or maybe some high-skilled QA, or who should do, who does it in Grep, and what's the best practices you think?
Sure. I mean, I would say definitely we don't need a dedicated or some highly skilled person to do this profiling. I mean, I just saw this lecture in Google I/O 2018, and I was able to do the profiling by myself. So I believe every programmer should be comfortable enough to do the profiling. And I believe the Vital dashboard should be looked into very very frequently. We don't need a special QA for this. You don't need a special developer for this. Every developer, senior, junior, or even your engineering manager, you can do that. At Grab, we do not have a specific engineer who do the profiling. Anybody can do the profiling related to their domain.
Так, ну давайте поблагодарим докладчика.